All right, so let's do a really quick overview of this material. Right, I'm guessing that most of you know most of this, so stop me if I'm going too fast. But I'm assuming that hopefully you'll be bored with this, right? But I'm just going to go really quick. So HTML is just a plain old ASCII text format that allows you to format pages, right? The browsers parse the HTML. They look for tons of these elements, or sometimes we call them tags that look like this, right? Right, and these are clues to the browser to format certain content to have a particular format. So H1 is one of the simpler ones, right? That allow you to say, I want this big, right? Also, it takes up the entire width of the page, right? So, for instance, that big HTML headings, right? That was created using an H1. It takes up the entire width of the page. When a browser looks at this and looks at these tags, notice it has an opening and closing tag, right? They look at this and they assign a particular rectangle of the page to render this, right? If you hover over them and you look at the actual content, right, and you see the content, and you hover over the H3, notice that the width of this H3 takes up the entire width of the page. You see that, right? We refer to this type of behavior. We call this as block, right? The element is behaving as a block, right, as opposed to inline, which we'll see in a minute. A block element takes up the entire width of the page and adds vertical spacing to the page. So as opposed to, if you look at just this one, well, let's see if I have an inline. Do I have an inline? I don't have inlines. HR, no, that's HR. These are all blocks. Do I have any? I don't have any inlines. All right, I'll show you an inline when I get to one, right? But basically, the default behavior of rendering anything on the page is that the browser renders from top to bottom and from left to right. Okay, and as it renders from left to right, when it has no more space on the right-hand side, it just wraps, right, and it starts off on the left-hand side again, rendering from left to right. Yes? Okay, and so you'll notice, for instance, if this piece of content doesn't fit, notice that it wraps. See that it wraps? Right? It doesn't fit and it wraps. That's the behavior that inlines have. Right? It doesn't fit. I'll try to render from left to right. When there's no more space, I'll wrap. Right? That's inline. And using those two policies for rendering, it treats certain elements treats them as blocks, and certain elements treats them as inline. Right? And we'll learn which one is which as we go. All right. Okay. Paragraphs is yet another block element, and they're used to add vertical spacing, right, above and below. Typically, if we just remove all tags, and we add white spaces ourselves, right? For instance, if I grab this and let's create a lectures here so that you see what I'm talking about. Let's see. Let's go to plugin, public, lectures, undergrad, and I'll just create here an HTML or HMTL. Let me change that. So HTML, and let me add an index here. Right. If I grab this and I remove, all the elements, if there are no elements, right, and then I navigate to my local host. Where's my local host? Is that my local host? No, that's not my local. I'm gonna go to local host, right? If I go to lectures and I go to undergrad and I go to HTML, there it is. So this is how it renders, right? It's just one blur from left to right, from top to bottom, okay, with no formatting. And you might ask, well, what's my formatting? All right, I added all these nice white spaces, these all new lines. So our browsers are not yet smart enough to understand this formatting, right? This is only for human beings, right? We're using our own parsing, our brains to make sense out of this, and are creating this this virtual categorization of things, right? We usually use white spaces and tabs and new lines, right, to categorize things. So browsers are not smart enough, not yet anyway, that they need to explicitly be told how do you want to render things, right? So we explicitly told it that we want for this to be a header, for these to be paragraphs, and so it adds the white spaces and whatnot. Everybody okay? Right? Notice that this H1 is a little bigger than this H2, right? This is a little bigger than this, right? All right, let's see, what else? Let's continue. Paragraphs. Tables. Tables are used for what you might expect. They for creating tabular data. So here's a very simple table. Let me grab. Can I copy this? Can I copy that? Right. If I copy it and bring it up here, and I say H1 tables, and I paste that content, and I render it locally. I have tables. There it is. So this is how they render by default, right? They provide headers, they provide columns, rows, and tables. The original intent was to be used for tabular data, to display records and where each item had the same kinds of attributes, right? And the headers label all these types of attributes, right? They were quickly misused early on when at the beginning of when the World Wide Web just came out. They were misused to lay out the pages, right? For instance, many folks were using it to render content side by side, right? As using like columns, right? Because HTML by default, out of the box doesn't support, writing things in columns or putting things side by side. Everything is just from top to bottom, from left to right. That was the original intent of HTML for rendering, research papers with abstracts and sections and whatnot. It was just not meant for displaying magazines or newspaper or articles, things like that. That was not the original intent. So folks misuse tables to use it to be able to do this. Right? They would create these columns. Do not do that. Right? Don't do that. It is universally considered to be a very bad practice to use tables other than for table content, or for tabular data, right? Not for layout. Do not use tables for layout. Right? You lose points. Right? Do not use them for layout. Okay. CSS. Here we have CSS. CSS is a different language. We'll be using those three languages quite a bit this semester: HTML, CSS, and JavaScript. HTML typically is used for laying out the page, right? Giving the rough layout of the page, right? For delivering the content. But it is not used for choosing how things are going to display, what colors they're going to display, what kind of fonts, right? Early on, again, when HTML just came out, it was very common that within HTML we would put all sorts of styling, right? Colors of fonts, colors for backgrounds, color foregrounds, and things like that. Again, that became a nightmare to maintain. If it was just one or two pages, it was okay. But when you're talking about hundreds of pages, then it becomes a nightmare to maintain. So we quickly came up with a different mechanism where we would put all our look and feel code in a separate file, right? Or using a completely different language called CSS, or cascading style sheets, right? So just like HTML, it declares how things are laid out. CSS is used to declare how things should look, what colors, right? What fonts to use, what foregrounds, and things like that, right? We'll come back to CSS a little later, right? But they're both static, declarative languages, right? As opposed to JavaScript, which is a functional programmatic language, right? All right. So how about lists? List is also a very useful piece of HTML that allows you to just list things, typically in a vertical, but you can certainly do horizontal lists, and we'll see that a little later. You can do bullets or numbers, and here is the code. Here we have UL. I'm going to use that quite a bit. UL meaning unordered list. So we use the bullets, and these are the line items. Here we have an ordered list, OL. So that's 1, 2, 3, or I, 2 I's or 3 I's, or the Roman numerals. Here I'm adding a class. I'm attaching to the horizontal list. I'm attaching a class that is being declared in CSS. Notice the name JGA-horizontal. That's me. There it is. It's declared here, right? And it says that I want to display it inline as opposed to blocks. Normally, this renders horizontally. So if you look at this, if you inspect it, right, and you hover over it, notice that it takes up the entire width of the page. This LI, see that? It takes up the entire width. So it's behaving like a block, right? But we can tell CSS to change the behaviors. Things that normally would behave as blocks, we can say, no, I want it to behave like inline, right? So for instance, here this JGA horizontal is attaching rules that say I don't want block. I want these to behave inline. And notice that indeed they render from left to right, right, and on the same line, right? But for that, notice that we had to tell the browser to change the display policy, where by default it would be blocks. We're overriding it and it said, no, those LI, those line items in there, I want them to display inline as opposed to blocks. Okay, we'll come back to CSS a little later. Right now, just let's talk about HTML. Tables, we talked about tables, lists. This is too big. And then you have quite a bit of form elements that allow you to create all sorts of forms. We're going to be using these quite a bit. These are there's a whole bunch of type of them. Here we have form. Forms are used to declare forms that you can fill out, right? In this case, we have input fields. Yes. And this is the old way of what you would use forms for, right? You would submit the form to the server for handling. We're not going to do that. And we're going to do that programmatically using JavaScript to do that, right? We're not going to use the default behavior for submitting data to the server. We want to get a hold of it before we send it out to the server. The only thing that I'm going to point out here that might be new to you is that notice that here we have these labels. Labels allow you to create a label for a particular input field, and we are tying these together, saying that this label is for this input field that has this particular ID. See that? And so we're tying that these guys are related to one another. And what it does is that it creates the following behavior. Right? Typically, if I click on a field, obviously it becomes its focus. Right? You can start typing, and that's true for any field. What's new here is that if I click on the label, also the field becomes also active. See that? That's particularly important for small screens, right? For mobile phones, where you want to make sure that you increase the area that folks can touch, right? Not force folks to have to peck and click on that particular input field. If you can give them a bigger area to click on, then the better experience they'll have. So certainly make use of that behavior, especially with checkboxes. And yes?
Just going back to what you said about not using the forms submission
Yep.
the old way, are you talking about instead just using the ng directive, the Angular?
Yes. Yep. Right. We're going to be using Angular to bind to the model. We'll take a look at the model, verify anything before we send it out to the server to do any validation. So as I was saying, this behavior is particularly meaningful with checkboxes and radio buttons that on the screen, on a small screen, on a phone, they're so hard to to get a hold of, right? So again, by adding these IDs, allow you to click anywhere on the piece of text, right? And it becomes active, right? So any area, anything you can improve the behavior for users for small screens, the better. Okay. Radio buttons allow you to select just one. They're mutually exclusive. To accomplish that, that's not for free. You need to be mindful on how to achieve that. So input fields for radio buttons. Here are the radio buttons. Where are they? So here are radio buttons, and so let's select that. And by default, they behave the following way. So let me grab let me put that here. So we'll do H1 radio. Oops, did I copy? No. Paste. Yeah. So by default, this is how they behave. So by default, you don't have a name, right? By default, you do not have the name. Right. So if we refresh here, by default, you can click on them, and they're not mutually exclusive, right? By default. So to make them know that they are somehow related to one another, right? You need to give them all the same name, right? That's how the browser knows that okay, they have to be mutually exclusive, and the value for the field favorite color can only have one value. Can either be yellow, blue, or red. Okay, so it knows that if you select one, it'll unselect all the other ones. Yes, this is actually the opposite for checkboxes. Right, checkboxes actually behave the opposite way. Right. So we have checkboxes. Right. If we render checkboxes by default are allow them to behave so that you can select more than one, right? More than one. So they're not mutually exclusive, meaning all these apply, right? But what if you have several checkboxes that are related to one another, right? So where you might have favorite colors, favorite genres, favorite books, so you have a lot of checkboxes, right? That are related to one another, but they're mutually exclusive from each other, right? They don't have anything to do with one another, but only for a particular category, right? So for that category to work, they all have to be part of the same name, right? So if you select on these three, they all apply. That makes sense, right? As opposed to checkboxes, if they're the same category, only one of them applies, right? And they're mutually exclusive, right? And you can have different radio buttons for different categories, right? Where you have 3 radio buttons for this category, another 3 radio buttons for this other category, like yes, no, yes, no, yes, no, yes, no, right? For different questions, yes, right. And the way that they become mutually exclusive is that they become part of the same name, right? What else? Anything else? So these widgets, these date widgets, are new in HTML5. They were added so that with the intent that we want to strong type as much as we can, right? Whatever information the user types, right? So as much as we want, as much as we can, we want to avoid having the user having to actually type something, right? Because typing is so error prone, right? So as much as we can, we would ask for, if we're asking for an email, we want it to be validated, right? We want to make sure that at least the browser knows that it has to have an @ sign. It should have a top-level domain. You should have a dot and a date of birth also. It doesn't allow you to type letters, right? It allows you to type values, number values, right? Oh, that's a big year. But it has these widgets. Now, the beauty about using these widgets is that when you use them on a phone or on a tablet, it uses a native widget for that particular OS, right? So it will use the native iPhone widget or the native Android widget without you having to do anything. You don't have to do anything. You just have to declare the input field to be of type date or of type email, or of type phone number, or of type URL, right? So if you strong type them, the phone will automatically show you the correct keyboard, right? If it's an email, it'll show you the email keyboard, right? If you say it's a number, it'll show you the number keyboard, right? You don't want everything to just be the QWERTY keyboard, right? You want it to be context sensitive on what is a piece of data that you are asking for. Also, the dropdowns, they render like this on a desktop. On an iPhone, it would render, you can scroll through a whole bunch of these, right, and select, multi-select. On Android, would also render differently. So it renders differently for different browsers, right? For the dropdown, they're implemented using the select and the option. Notice that a common thing to do is that is to show in the dropdown a human readable piece of text, perhaps even a sentence, right, meant to be consumed by a human being, but the actual value usually is a piece of token, right? That is some key that is used for when you submit this, right? Is some key that means something in some data model for the server, right? So this is a very common thing to do. So this is all caps is a very common thing to do with constants. What else? Okay. All right. I think that's enough for that. Okay. I'm assuming that you know most of this, right? There might be a nugget here and there that I'm filling in, but I just want to make sure we're all on the same page. Form, semantics, anchors. So anchors are used for linking, being able to navigate, being able to click and navigate to a particular page. Now notice this behavior here, right? Where this table of contents, see that? This is a very common thing to do. For instance, if you go to Wikipedia, there might be a table of content at the top with lots of links. So you can use them for navigating to different locations in the same document, right? And the way you accomplish that is that you use the hash sign. See that hash sign? Right? You click on the hash. That means this link, this hyperlink, right, is referring to something in the same document. Meaning we're not going away to some other document. We're staying in the same document. Jump to some other location down below, which is declared using the ID. So this what, if you click on this hyperlink, it navigates to this location. If you click on Y, it navigates down to Y, and so on and so forth. Yes? Well, this hash mechanism, this is how all MVC libraries implement single-page application, right? What Angular and all these other MVC libraries, what they do is they hijack this exact mechanism. Right? They put JavaScript code in place to listen for these hashes. Right? There's a whole API, browser API that you could use JavaScript to say to listen for changes in the hash. If the hash changes, you can listen for them and say it says I want to do something. Well, what Angular does is that if you click on different hashes, that means you're trying to navigate, right? But it's a single page application. You're not going anywhere. You're staying here in this page. I'm just going to show you different pieces of content, right, strategically to fool you into thinking that you're navigating, whether you're going here, there, or everywhere, right? And the way Angular and all these libraries do it is that they hijack this mechanism that has been around for ages. It has been around from the beginning of HTML. Its original intention was to be able to navigate and stay in the same page. That was the original intention, right? The other cool thing about this mechanism is that is back button friendly. If I click on something and I click on back button, it just goes back where it was. Right? So it completely fixes a huge problem that pesters server-side applications, right? The back button problem of server-side applications, right? Where usually on a server-side application we say don't touch the back button, right? Use our buttons to navigate, right? So don't use the back button. Okay, this completely fixes this. Users can use the back button all they want. Back button, forward button is fully supported because it was baked into the HTML from the beginning, right? It's been there for forever. Anyway, we'll come back to this a little later when we introduce Angular next week. So anchors. Here are a couple other anchors that allow you to navigate to outside places, right? Or navigate and navigate, but then populate a local iframe, right, and show content locally on an iframe. And we'll see that a little later. CSS, as I mentioned, is a so it used to be that inside of HTML, right, of HTML document, it used to be just plain old HTML, right, and it was pretty good for the first year or so when HTML just became so popular amongst academics and academia and started just exploding. But quickly, folks started to look at what else could we do, right? And all sorts of new technologies came that started making its way inside of HTML. And it was not uncommon that inside of one HTML document you could see 3, 4, 5 different technologies all in the same page, right? You had Java applets and ASP components, and you have CGI in the back end. You have all these different things that were all embedded in one single page. You have layout, you have look and feel, coding. So it became fairly complex. Today, all these mechanisms have matured into their own fields, and folks can find a career just focusing on just front end, or only focusing on back end, or just focusing on design. They're complex enough that folks can specialize in each one of these aspects, right? In this class, we're going to kind of wear all these hats, right? We are going to do back end, we are going to do front end, we're going to design and everywhere, right? So anyway, so CSS is the part. It's a technology that allows you to style pages, and you can do it internally from within the HTML. So for instance, the most egregious way to do it is to take a piece of code, a piece of HTML, and say, "Hey, I want this to be green." Right? Don't do this in class. Right? Don't do this. And so by using the style tag, right, or the attribute, you can change different aspects of that particular H2. And so you don't want to do this. This is a very hard thing to maintain, code to maintain. You would have to, if you want to change the color of that particular H2, you need to open up this document, go in and make the change. It makes it very hard later on if you have hundreds of pages and each page has its own style, right? It's a nightmare to maintain. Instead, what we do is that we grab all these transformations, all these stylings, right, and we group them together in a reusable file, right, that can be maintained by somebody who's dedicated to this. CSS order of precedence. So here's another example. Okay, so as I mentioned earlier, so a better solution is instead of declaring it locally on a style attribute, is that instead we refer to it as a separate file, right? Completely different file outside. The improvement here is that if you have hundreds of files that are referencing the same style sheet, right, it's very easy to make blanket modifications to an entire website, right, without having to visit hundreds of pages individually. And you can optimize and do all sorts of really cool things. Selectors. So the way CSS works is that so here's the HTML document, and the HTML document is typically referring to refers to a separate document, right? So the HTML refers to a CSS using the link attribute. And that CSS now, once it gets loaded into the HTML document, can then refer to different portions of the HTML and say, what do I want to do with each portion of that HTML? You can say, hey, grab all the H1s, right, all the H1, and make them all blue, right? Or change their width, or change their height, or change their font, or change their background, their foreground, right? Make them skewed, make them bold, make them whatever you want, right? Make them justified left, justified right. And the way they work is that they refer to different pieces of the document. So the original document might have an H1, might have a paragraph, might have a div, might have different portions of it. And from CSS, you can declare and say, hey, grab all the H1s and do the following transformation. Make their foreground color red. Okay? Right? That's how they behave. Now, the problem might be that what if you have ambiguous transformations that you find somewhere in your document? You say this H1 says that they're red, and this other H1 says they're blue. Well, which one do you believe, right? Well, first of all, you want to be able to avoid having to get into those issues of inconsistency. Right now, this H1, what this says is that all H1s, right? All H1s, I want to make them red. If you have two H1s, basically there's a rendering engine that looks at this and says, well, the last one wins. Right? The last one who told me what to do, that's the one that I'm going to go with. All right? And it has a set of rules by which it handles ambiguities. Right? So this rule says I want all H1s to be red. And do I have any H1s being red? I guess I don't. And that's because, let's see. That's because I have another rule that says I want all H1s that have the following more specific rules here that have a class called blue color. Then I want it to make it blue. Right, so for instance, if you go to the H1, notice that we have an H1 here, and we have another H1. No, I guess that is the only H1. Yeah, that's the only H1. Right, and notice that it has the class color. This has class blue color. See that? Right, you can associate different classes to an element, and then you can refer to them as belonging to a family. Right? Meaning we're all blue. Like we're all part of the family of blue color. Right? So any element that you apply this class to will become blue. If you apply it to the paragraph, then the paragraph becomes blue. Right? Or if you apply it to some line item, it'll make that line item blue. Right? So you're declaring a family of behaviors, right? That you can then apply and paint things with that behavior. Yes, right, for that look and feel, and so you might ask, well, how come H1 says it's red, but H blue is blue? Why is this one winning as opposed to this one, right? And the reason is that that's another part of the rules that the browser follows when it has ambiguities, right? So what do I do? Is H1, do I make them red, or the other one says to make them blue? Which one wins? And earlier I said, well, it's the last one. But also it has an additional rule that says the one that is most specific, right? The one that is most specific wins. And this one is certainly more specific, meaning this one refers to all the H1. That's very broad, right? You're not being specific about any one particular H1. It's all H1s. Whereas this is saying this particular H1 that has that class. So it's more specific, so it wins, even though this one is declared later. Make sense? Right? So this dot that you see here, this dot is what we refer to as a class selector. Right? It means I want to be able to select different portions of my document. Right? I want to select this H1. So how do I refer to it? Well, I could refer to it as plain old H1, or I can be a little more specific. The H1 that has a class blue color. Right? So how do I say that? Is H1 dot blue color. So dot is for classes. Make sense? Right? So it's referred to as a class selector. Okay. So here we have an example of having an H1 that has the class selector blue color, and then the same class being applied to a paragraph down here. See that? Blue color. See that? And yes, CSS is saying dot blue color, right? So notice that this is saying everyone who has the class blue color, irrespective if it's an H1 or a paragraph, I wanted to paint them blue, right? So it's again, it's a broader thing. Or you can be very specific and say only the paragraphs who have the blue color, I want to make them blue. Make sense? All right. Let's see, what else? IDs. ID selectors are the most specific. IDs, as the name suggests, IDs are used to uniquely identify an element on the page, right? Meaning you're naming or you are identifying this particular element to have the unique identifier head, right? And we can specifically refer to this by saying H1 and then hash head. So for instance, hash head means I want the H1 that has the ID of head, right? And presumably these are meant to be uniquely in the page. So you're not going to use the same ID more than once in the same page. Yes? The class is meant to be used more than once, right? We have many elements that belong to the same class of elements. All right. Let's see. Class selector, we did that. ID selectors. Inheritance. You can have if you have content, right, that is nested. For instance, you have this outer div that contains several elements inside, like H1 is a child element of the div. Also the paragraph and this other paragraph, these three are siblings, right? They're both siblings, and they're all children of the parent div. Yes? You have this hierarchical structure. And notice that this paragraph has text, right? And then it has this embedded bold element in here. See that? So the bold here is a child of the parent paragraph. Yes? Right? So CSS allows you to declare attributes and features to parent elements that then are inherited by all the child elements. So for instance, if outside I say that the paragraph has color blue, okay, that means that also the inherited here will also be blue unless the child overrides their parent, right? Just like we have an inheritance in object orientation, we can have that the child inherits from the parent, or more likely the child overrides the parent. They don't like the way their parents do things. They override their parent and declare their own behavior. So here we have the bold tag, this B over here, overriding their parents, saying, I don't like your blue color, I want to be red. Okay? And it's declaring its own background to be green. Make sense? Right? And the result is that, there it is, we have the inherited is background green and foreground red. If you want to play around with this code, you can go to JS Fiddle and play around with it. So for instance, if we remove the color from the background, right, and we run this again, notice that indeed the foreground becomes blue, inherited from the parent. See that? Right? If I put it back and I rerun the example, and notice that it overrides the foreground color and it becomes red. Let's see, what else? All right, inheritance, we did that. All right, enough of CSS. Any questions so far? All right, the block model. This is something that we're going to see a lot this semester. Whenever we're rendering something on the screen, the browser is thinking, okay, what area, what rectangular area am I going to give you to render yourself, right? And it uses as its base, it uses the two policies I mentioned earlier, whether you're a block or you're an inline. Yes, if you're block, you're going to take up the entire width of the page. You're going to give some vertical spacing. Yes. If you're inline, you're going to render from left to right, and when there's no more space, you're going to wrap. Right. Those are the two major mechanisms or policies. After that, the two other the other big policy on how the browser decides what renders where, right, is called the box model. The box model, and what it is that if you inspect any piece of content, okay, if you inspect any piece of content, let's put this on the right hand side, and you if you select and inspect this, right, it'll tell you the box model on the inspector. It'll tell you, right, this particular content you're looking at, which is H3. This H3, see that? I'm hovering over it. Says that its margin above and below are 20 and 10. See that? Right? That it has no border. Right. So notice that it's not rendering any borders on the right hand side. It has no padding. And it has a content, right? See that? And you can modify this. You can use CSS to override this behavior, right? This is the default CSS that the browser has for that particular element, H3, right? It has that all H3s will have a margins of 20 and 10 below, but I can change that. I might make this 40, right? Notice that it became bigger, right? I can change its borders. I do want borders, right? I want 10 and 20. Oh, it's not letting me. What's going on? Oh, it's putting it. It is putting it a border above and below. Someone is overriding me. How about the padding? Can I change the padding? Okay, so padding left 40. Okay, there it is. So it's putting some padding on the left hand side. If I hover, it will show me all the padding all around, or padding above 60, right, or some padding below 30. Okay, and some padding on the right 10. Right. So understanding how all gets shifted from left, right, above, and how it interacts with other elements around it. Understanding all that rendering, right? It's referred to as understanding the box model, right? That the actual width and the area that a particular element takes up is based on the margins, the borders, the padding, and the inner width, inner height. Okay, so if somebody asks you what is the overall size of something, you need to ask, well, what is the margin? What are the borders? What is the padding? What is the inner width and heights? Yes? Okay, and you can use CSS to override all these look and feels, right? So for instance, on that H3, notice that we have these margins, these paddings, and the padding border. The border we can say that is solid and it's red. It's not liking. Why it's who's overriding me? Somebody's overriding me down below. All right, whatever. The overview also is another element down here. It's a paragraph. The paragraph, this is the default box model for the paragraph. It has no padding, it has no border, and no margin. It just has some size over it, and you can override all those things. All right. All right. So take a look at the CSS box model and play around with it. You can change the how borders are rendered with dotted lines, dashed lines. You can change the colors, the width of the borders. You can also turn on and off how things are visible and invisible. You can also control the depth of elements, like what appears above anything else. Right? Typically, everything nothing overlaps in HTML by default, right? Everything has very well defined rectangle that gets rendered, right? But you can start mucking around with starting to move things around, right? Where we can shift and move things around on your own. And in that case, certain things will overlap on top of things, right? So you need to be able to control, the depth, right? What renders on top of what. So here I have a couple of experiments that you can play around with that. Like for instance, here we have a piece of content that if you go to JS Fiddle, it will show you that there we go. So we have 3 pieces of content. Box 1, which is shown here. We have another ID of box 1. Then we have box 2 and box 3. There's 3 boxes, and here we're overriding their sizes. Right? We're saying box 1 is going to have background red. Box 2 is going to have a background blue, and I think that's it. Only those 2. And notice where they're rendering, right? They're rendering like one on top of the other, right? What's up with that, right? And what's happening here is that we're changing their border, right? A width of 50 pixels. We're changing the border color to be green. Where's the blue box? Where'd it go? Oh, there it is. The blue box, right? Here's the blue box. We're changing the width of the blue box. Right? Typically, it renders, it has the width of the entire width of the page. But here we're overriding it and giving it an explicit width. We're saying that the width is 300 and the height is 300. So we're overriding it. The width, notice that it's bigger, it's taller than I need, right? But it's not as wide as I need it. See that? So it's starting to wrap, but it's too wide or too tall. So when you start changing the default behavior of what the browser says of how things should be big or tall, right? Then you start to have to deal with the consequences. For instance, over here we have an example where not only are we changing the width and the height, okay? Not only are we changing the width and the height, we're also changing the position. We're saying, hey browser, I don't like the way you're rendering and positioning things on the page. I want to do that. Right? I want to take over the behavior of where to put things on the screen. Right? So here we're telling the browser says, I want to absolutely position this, right, as opposed to relatively. Typically the browser renders things relative to each other, right? As it renders things at the top, push things at the bottom, right? And things on the left, push things to the right. Right? That's the default behavior. Here we're saying, no, I want to take over that behavior. I want to render myself, and I want to put it. I want to put it right here at. I want to put it measure 50 pixels from the top and 50 pixels from the bottom, from the left, right? And notice there's 50 pixels here and 50 pixels there. We can change that and play around with this. You can say 100, run, and move it to the right-hand side. And when that happens, notice that the content down below. Notice that it's showing under. See that? Right? And probably that was unintentional. We didn't mean to do that. But it's the consequences of us overriding the behavior, the default rendering of these rectangles, right? If you remove it from the normal calculation, right, then the browser says, well, if you're putting it on the screen, I have no idea when it's going to end up, right? So the bottom, which normally would display underneath, right? There's nothing pushing it, right? There's nothing pushing it. So I'll render it where it would fall is as if your element is not even there, right? Notice that if I remove this position, if I comment it out and I rerun it, notice that it becomes now part of the rendering again. See that? Pushing everything down where like it normally would, right? But if I override the rendering, right? It says, okay, well, you have removed it from the normal flow of the content, right? I'll render the rest myself. Okay, you're responsible for that content. Make sure? Make sense? Right? We'll come back to this a little later when we see Angular and CSS and how they work together. All right. Thank you. So please go over these sample pieces of code, right, of CSS and HTML on your own. Tomorrow, I'll assume that you've looked at all the videos and play around with all these, and we'll start implementing the assignment earnestly. All right? Thank you.